Hi primary teachers, welcome to Best Practices Weekly. Today we're going to finish up a special on an article called Increasing Participation Through Differentiation, where we're studying a math framework for a math block. And last week in the video we covered the first two parts of the math block, and today we're going to finish up covering the last two parts, talking about problem solving in small groups and how to individualize math fluency and math maintenance through math boxes. And just in case you missed it last week, the article is called Increasing Participation Through Differentiation and can be found in the October 2012 edition of Teaching Children Mathematics. The Balanced Mathematic Framework provides many opportunities for you to differentiate for all learners and for all learners to participate in an equitable manner. The Madison Metropolitan School District is the district that actually created this mathematics framework, and they provide professional development for their teachers on how to carry it out in their classrooms. Let's quickly review the four parts of the framework. The first one is inspecting equations, which is whole group work that takes about 5 to 10 minutes of your math block. Number work is again whole group, taking 15 to 25 minutes. Problem solving is in small group, which is 20 to 25 minutes per group. And fluency and maintenance is something that children are working on individually and sometimes with groups of peers doing a collaborative game that takes about 25 minutes of your math block. So this week we're going to start off with the third component, which is problem solving small groups. So when the first grade teacher that we studied through the article is working with small groups, she's pulling students based on assessment that she's done, and so she's trying to pull students who are about at the same place that she can present with a story problem from whichever strand of math she's working on large group. But she can kind of customize that story problem for each small group that she's pulling. There's a lot of collaboration going on in small groups, a lot of strategy sharing, a lot of crosstalk between students, and talk individually between the teacher and the student. High levels of support are offered when needed, and the teacher is really able to gauge what kind of strategies and tools students have in their toolbox, and they're able to add more strategies into their toolbox because of the strategy sharing that goes on from peer to peer. So a lot of the problem we have in primary classrooms is what happens when you're pulling a small group. What is the rest of your class doing? And teachers always say, what is the rest of my class supposed to do while I'm pulling a small group? Well, this framework provides a way for you to differentiate work for each student that is a little bit of work up front on the teacher's part, but it pays huge dividends. And it's through individual math boxes. And these math boxes are geared to provide fluency and math maintenance work for each student to work on during the small group time. Students' math boxes are equipped with the menu of activities geared toward developing the fluencies that they need, so you can differentiate the activities in each student's math box. Often these are paper and pencil games, sometimes dice games, sometimes card games, but always things that have been modeled whole group so that students know how to do the activity independently. So let's look a little bit more closely about what math boxes look like in a classroom. Again, each student has their own. The purpose of it is to develop fluency or fluency maintenance for students who need it. It would be a great time for teachers to find activities that can help fill that gap in knowledge that some students have. The menu in each box is customized, but with a variety of dice and card games, there are lots of ways that you can just make the game a little bit harder or a little bit easier. So I can see where 1 or 2 dice or card games would really reach all students. There are sometimes choices in the math boxes where students maybe are playing a math center game with another person. Sometimes they're working independently. It's highly student-centered, and so student choice is essential here. But these games have all been modeled whole group, so students know how to play. Teachers want to feel confident that students are playing the games correctly, so they're not practicing math skills wrong, and we want to be able to catch their flaws in learning early in the game. So modeling these for students ahead of time is really important. I think this is a great way to engage students during small groups. So looking at this framework, let's pick out some of the best practices to take back to our primary classrooms. I think that it is something that every teacher can do to make sure that we are inspecting equations. That was the first part of the framework, and talk about that the equal sign really just means the same as on both sides of the equation, to get our primary students thinking algebraically, because even within Common Core, algebra is really where it's at. We can definitely create problem-solving groups based on data and our assessment to make sure that we're customizing those strategies and problems for each child while still teaching within the same concept. We can create math boxes for each child that are personalized and differentiated. And any curriculum that you are using in your classroom can be adapted to meet this framework, and it will give you student-driven instruction that will increase your students' participation and differentiation. I hope that these best practices are helpful to you, and I would love to hear about how math boxes and your problem-solving groups and your algebraic thinking notebooks and journals are going in your classrooms. Thanks for joining us.